Alright, so let's begin taking notes on page 13. A few things to keep in mind, actually mainly, you're going to see those two symbols quite a bit, and they represent negative and positive. Okay. So the first point, the charges on ions are quite predictable, and we can use the periodic table for that. So if you look at the periodic table, every element on this column will have the same charge. All the elements on this column will have the same charge, and so on. And they are related to valence electrons. That's why you can make that connection. So each column, all the elements will have the same charge. When electrons are removed or added to an element, the rest of the element stays the same, since nothing happens to the protons. The atom is still the same. So if I'm talking about lithium versus lithium with a positive charge, we still talk about lithium, but we're talking about neutral versus a charged, right? A charged atom, but it's still the same atom, it's still lithium. We represent charge by a subscript. So this represents charge, this represents charge, and this represents charge. In this case, this shows that oxygen lost 2 electrons. Oh, I'm sorry, gained 2 electrons, lost 1 electron, and lost 3 electrons. Okay, so let's take a look at this a little more closely. So let's just use a blank piece of paper for this. So you have a neutral atom. Okay. And you have a charged atom, where instead of say charged atom, let's begin calling them ions or ion. Same thing as a charged atom. Okay. And since we're talking about lithium, let's use lithium as an example. So you have here lithium, and then lithium plus 1. When we look at protons, neutrons are not really relevant here, so let's just talk about protons and electrons, and then we talk about protons and electrons here. So if you look at the periodic table for the number of protons for lithium, you would find that the number is 3. For neutral atom, the number of protons equals the number of electrons. Okay. So protons, protons, and protons. So there's 3 protons, and there's 3 electrons. The positive and ballast cancel each other out, and the final charge, so charge equals 0, right? The positive cancels with the negative. When we look at lithium, this other ion, lithium ion, again we'll have 3 protons. Okay. And this says that it lost an electron. How so? Because this is what's showing. So when lithium loses an electron, so it gives an electron away, all of a sudden there's only 2 electrons left, right? So there's 2 electrons left. So if you cancel out the charges, you ended up with this 1 charge that's not accounted for. So the charge of lithium would equals plus 1. Okay, because it has an extra proton. So that's what the plus 2 that you see here, the plus 1, the plus 3, the minus 2 comes from. Alright, let's continue our notes. There are 2 types of ions. One is a positive ion, and we call it a cation. Okay. And usually it's formed by metals. And then we have an anion, which has a negative charge. Okay, so cation positive charge, anion negative charge. and is usually formed by a nonmetal. Okay? So if you look at the examples above, we would call this an anion, a cation, and a cation. Okay, so next point, the charges on transition metals are not predictable, and we'll talk about them later. When we're talking about electron transfer, the whole reason why the electron transfer happens is so that the atom can become stable. And when that happens, you're going to notice that they begin to look very much like noble gases, which has a full orbital, right? Full orbital. And that's the whole point of actually atoms come and bond, is so they can achieve a stability and have full orbitals. So that's the whole goal for bonding. Pretty much to reach stability, to have a full orbital. Alright, so before you begin your activity, we do need to review Bohr diagrams. So let's review some rules for the Bohr diagram. The first rule is you need to identify the number of protons, neutrons, and electrons. Okay, that's the first thing you need to do. Number two, you need to know that protons and neutrons goes in a nucleus. Okay, so it goes in a nucleus. Three, you need to know that electrons go in orbitals. The first orbital, you can fit 2 electrons, and then second, third orbital can fit up to 8. Fit up to 8 electrons. Okay. And the next thing you need to know is that the final orbital, or the outer orbital equals valence electrons. Alright, so now I'm going to ask you for you to try to draw a lithium and an oxygen Bohr diagram. You can stop the video right now, or if you need to see me drawing a Bohr diagram, you can just continue watching the video. So I'm going to do a Bohr diagram for nitrogen. Alright, so this is a Bohr diagram for nitrogen. And again, nitrogen. And this is just a neutral nitrogen. So we begin by looking at protons, neutrons, and electrons. And if you look at the periodic table, nitrogen, you have, I'm going to do it like this so you can see it. Nitrogen has 7 protons. And I said it was neutral, so therefore it's going to have 7 electrons. The total mass of nitrogen is 14, so 14 minus 7 equals 7, so it has 7 neutrons. Remember that I said the protons and neutrons go in a nucleus, so you'd write 7p, 7n, and then you kind of just draw a nucleus. And then electrons, I'll do it a different color, but the first orbital fits 2 electrons. And then the next orbital can fit up to 8, but we don't need that many, we only need 5. 1, 2, 3, 4, 5. So you can count, so there's 5 on the outside and the 5 valence electrons. Okay, so there's 5 outside and there's 2 on the inside, which makes it 7, and there's a total of 7, right? And I know there's 5 valence electrons also by looking at the periodic table. I could count. So 1 valence electron, 2 valence electrons, 3, 4, and 5. So So this is where nitrogen is, and this is everyone in this family has 5 valence electrons. Alright, I think that's it. You can go ahead and show me the Bohr diagram for lithium and oxygen.